Hi, I'm Luke Rayler, and today I will be presenting methane emissions from livestock. So, just an overview of what we'll be going over today. It's going to be what is methane, the sources of methane, the human and environmental risks, how is methane regulated, ruminant animals, enteric fermentation, manure management, along with methane mitigation strategies. Alright, so now looking on the fact of what is methane. Methane is the simplest hydrocarbon and it is an alkane just composed of one carbon along with four hydrogen. Methane is a very commonly used gas. It's used for homes, water heaters, along with rockets, and will be featured in the next SpaceX Mars missions coming up here from Tesla. So excited to see that. Methane is also a major component of natural gas, and it is known as a greenhouse gas, known for trapping heat in the atmosphere. So, looking towards the sources of methane, you have natural gas and petroleum systems, which methane is used for hydrogen production. Landfills, when they heat up, they emit methane. Coal mining, along with other operations as well. But the main sources I'm going to be focusing on today that revolve mainly around livestock is going to be enteric fermentation, along with manure management. Now, just looking at the human and environmental risks of methane, methane itself is 10% of all greenhouse gas emissions, and it is second priority behind carbon for EPA regulation and trying to abate greenhouse gas. It is a very short lived radical, which has a greater global warming potential than CO2. And one of the main problems with the increase in methane is that it affects the other amounts of atmospheric gases through secondary transformation. And the biggest risk is that it's a precursor to tropospheric ozone. Methane itself has been contributed to 50% of the rise of tropospheric ozone in recent years and can be attributed to about a million deaths. Just looking at the numbers here from the EPA.gov website, methane warms the planet 84 times as much as carbon dioxide over a 20-year period. Methane remains in the atmosphere for about 12 years. Globally, over 60% of total methane emissions come from human activities, and agriculture being one of the key emitting factors at 40%. So, how are greenhouse gases regulated? Well, the EPA did not start regulating greenhouse gas and the amount of emissions until January 2011, and they focus on both mobile and stationary sources such as automobiles and manufacturing processes. But due to me going over livestock along with ruminant animal emissions, they have not been regulated by the EPA so far. Now, finally, making our way to ruminant animals. These are animals that utilize a multi-chambered stomach system, also known as a rumen. Uh, the multi-chambered system includes the rumen itself, a reticulum organ, an omasum, and an abomasum, and this allows for the cellulose breakdown of very dense plant material that us ourselves as monogastric animals would never be able to digest. And as a result of this fermentation in the rumen, the CH4 or methane is emitted primarily through belching of the animal and can also be found within emissions of the manure. And some ruminant animals include the dairy and beef cattle, which is going to be your main category, sheep and goats, along with deer. Now looking towards enteric fermentation, this is the fermentation of the rumen. This is kind of what makes the methane emissions. The fermentation of the cellulose plant product, as I mentioned, stuff that us as humans cannot digest, in which the rumen microbes attack all this plant material and it creates volatile fatty acids that in which energize the animal, but as methane as the byproduct, all that doesn't get digested by the animal is then released as methane through the mouth. Enteric fermentation it contributes to the primary agricultural emission of methane, and it's 28% of all methane emissions. And enteric fermentation is the initial step in ruminant digestion. Now, looking towards ruminant digestion here, the plant material first enters the esophagus, and that's where it enters the rumen, where it is then attacked by the microbes and turned into volatile fatty acids. It goes into a reticulum where it's further processed, and then it's breathed out through the mouth here, and whatever does get digested cycles back all the way to the omasum, through the abomasum, and then finally through the intestines where it goes through basic digestive processes. Now, just looking towards the emission factors per head a year by each animal here. As you notice, just looking towards the cattle here, beef and dairy, they average the most per head per year. The one that stands out the most is going to be your mature dairy cattle, along with your mature beef cattle, but dairy cattle produce the most. And then bulls are their own separate carry, averaging about 220 a head. And we have to recognize that there's 1.5 billion cattle out there, so you take each one of those averages and multiply that by 1.5 billion, and that's the average amount of emissions per year. Just looking at other ruminant animals here, a lot of them can't even compete with cattle, but other than the water buffalo, which averages 116.8 pounds a year. Other than that, a lot of the smaller ones are not really worried about, other than sheep and goats, which have been increasing in population recently. Now looking towards manure management, and when it comes to manure management, we have to look at all forms of livestock. And when it comes to manure management, yes, it only takes place up of 10% of all methane emissions, but this is increasing due to the increasing population of animals, as you see on the left here. Most dramatic increase recently has been chicken, but steady climbs from all different animals here. And with manure, the methane is then distributed to the atmosphere through anaerobic decomposition. And with the increase in animals, the increase in methane is bound to see. So now finally looking towards methane mitigation strategies for both ruminant and regular animals with their methane from enteric fermentation along with their manure. The most feasible strategy, because the other strategies would include uh, abuse of the animal, containing them in small spaces so we could capture the gas, or even mitigating methane by mass extinction, and that is just not humane. So dietary manipulation is the most feasible route. We want to mainly focus in forage diets over concentrates because the forage allows for very fast digestion of the plant material. And with more forage based diets, we're going to be looking towards a 40 to 70% enteric fermentation from a lot of studies. And with this forage, it's going to increase animal activity and lifespan, but that does not mean we can only feed these cows grass and everything else in between. Looking on the right hand side here, these are some things we have to try to figure out and try to look upon to see what dietary manipulation is best for us. This includes grass fed versus corn fed, grass silage and maize silage, which is different from grass fed and corn fed, dairy cows and their need for concentrates, and also the use of fat supplements and antibiotics, in which some cases are inhumane. So looking at the best method here, our best method would be 100% grass-fed cows. This is not for dairy cows since they do require some sort of concentrate to fully have the rumen digestion. But again, this is going to be infeasible due to grass-fed cows being able to be free range and eat young nitrogen-rich grass is kind of impractical since American farmlands are not big enough to suit this amount of cattle. But the best possible method we can look to is the mixture of cellulose rich and carbohydrate rich. In my mind, a 60-40 grass and corn mixture would be the best way to go. The cellulose rich would be as in your grass to speed up the digestion. The carbohydrate rich would be there to possibly give the animal energy. Added fat supplements would be a decent route to go because fat supplements also increase the rate of digestion and reduce methane emissions, but again, impractical and inhumane in some sorts. And another method would be to try to get fresh grass as possible and avoid grass silage because with grass silage, it's old, matured, almost dead grass, such like hay, which it lacks nitrogen and it's not as cellulose rich as some would think. And thank you for the presentation, but here are some of the questions I have for the class. What are the methane what are the methane emissions regarding livestock? That would be answer C, A, and B. I need to change that to emissions. What digestive system does a cow have? That's going to be answer B, ruminants. Does methane have a greater global warming potential than carbon? The answer is true. Methane is a precursor to which greenhouse gas? Answer is A, tropospheric ozone. And is manure management a growing methane emission issue? True or false? True. Here my works cited, and thank you very much for the presentation.